But it turns out a pinhead 2 millimeters in diameter, a spherical pinhead, would be the equivalent of a pile of paperback books reaching from here to the sun. Just about. Or 500 times from here to the moon. That's paperback books I could store on just one pinhead of DNA. Or to put it another way, see, a 1,600 kilometer high pile of CDs. You know, a CD can store the entire set of the Encyclopedia Britannica, but a 1,600 kilometer high pile of CDs would be required to store what could be stored in just a single pinhead of DNA. The other way of putting it is a 40 gigabyte hard drive is not a bad hard drive, I've been told, but in fact a pinhead of DNA is 100 million times better. So you think our multi-gigabyte hard drive is something special. Well, God's information technology just leaves it in the dust. DNA by itself would just be like a blank hard drive. There's nothing there. There's no programs on it. So to program something, you need a programmer. So for DNA, you have to actually be able to write the messages on the DNA. Not just enough to have the DNA itself. You've got to write the messages on it. But you have to have a way of decoding the messages. For instance, my books are fine if you understand English. See, the English is a decoding system because it says that the sequence CAT stands for a furry animal with sharp, retractable claws. Okay? There's a code there, the letters into concepts in your mind. But the letters GIFT in English, they stand for a present. Is that reasonable? But what about in German? It means a poison. And that's been a problem, I think, when the anthrax scare was on. German postal workers didn't want to handle packages marked gift. So you had the right message, but the wrong decoding system. And it turns out that the decoding system in the cell is made of lots of protein. It's mainly the ribosome. It's a very complicated set of machinery, the ribosome. There are about 50 or so components to a ribosome. But the main amazing thing is the instructions to build the ribosome are on the DNA. But you need the ribosome to decode the DNA. So that's a real chicken and egg problem, isn't it? Because you can't have, there's no point having the DNA unless you have the ribosome to decode it, but you can't get the ribosome unless you have the instructions for it in the DNA. And one of the world's greatest philosophers of science, Sir Karl Popper, recognized the big problem. And he said that the origin of life and genetic code is a disturbing riddle. The genetic code is without any biological function unless it's translated, unless it leads to the synthesis of proteins whose structure is laid down by the code, but the machinery by which the cell translates the code consists of at least 50 macromolecular components that are themselves coded in the DNA. So the code can't be translated except by using products of its translation. And he goes on to say, this constitutes a baffling circle, a really vicious circle, it seems, when you attempt to form a model or theory of the genetic code. Thus, we may be faced with the possibility that the origin of life, like the origin of physics, becomes an impenetrable barrier to science and a residue to all attempts to reduce biology to chemistry and physics. So he thinks the origin of life is a real, it's a block for the materialist. The materialists have this conundrum trying to explain the origin of life from non-living chemicals without God. To give you an idea of how the chemicals are, what the DNA is coding for is all sorts of different types of proteins. Here's one type of protein, the fibrous protein. It makes your hair, and you see how it's at base it's curled up. You see it's got the alpha helix, it's a coil, and you've got coils of coils bundled together, and then you've got bundles there into a hair cell. So you see how complicated. You've got the protein, you've got bundles of the protein, and then you've got further fine structure. And that's in your hair. You didn't think hair was that complicated, did you? The other type of protein is a globular protein. You see, these are very important and very highly designed for certain functions. Now, one of the most important functions of a protein is the enzyme. And they speed up reactions by many orders of magnitude. Order of magnitude is a power of 10. One order of magnitude is 10 times. 2 orders is about 100 times. 3 orders is about 1,000 times. And it turns out there's a vital reaction to make the building blocks of DNA, and it needs an enzyme to speed it up by 18 orders of magnitude. That's 1 followed by 18 zeros. That's how much the reaction is speeded up. And in fact, without the enzyme, it takes 78 million years to work instead of being a few thousandths of a second. Now, the cell just couldn't survive if it took 78 million years to make this vital reaction. The cell would have long since broken down by then. And even more recently, and this was only discovered last year, 2003, it is last year, isn't it? Yeah. And this one speeds it up by 21 orders of magnitude. So without this enzyme, a reaction would take 1 trillion years. Now, even the Big Bangers think the universe is only about 15 billion years. And so this is about 100 times even the evolutionary age of the universe that this reaction would occur if it didn't have this enzyme. And here's one of the researchers involved in this discovery of the way enzymes work, how much they increase the reaction rate by. He said, without catalysts, there'll be no life at all, from microbes to humans. It makes you wonder how natural selection operated in such a way as to produce a protein that got off the ground as a primitive catalyst for such an extraordinarily slow reaction. Now, this is quite a statement of faith there. Well, because natural selection couldn't have done it, because you haven't got a living cell without this enzyme to work. And if you haven't got a living cell to reproduce and pass the information on, natural selection can't work. But it just shows you that he's got this preconceived idea, this bias, that somehow natural processes must have made the first living cell.